In a previous video I was talking about two methods to approach microsound processing. One that is based on use of granular unit generators inside of this Ndef, and another one which is based on messaging server for every new grain. And in this one I would like to take a closer look at the first approach. And as you can see, here is the Granulator and Ndef, which is the same thing as was described in the first video on Microsound, or the previous video on Microsound, let's call it that, because there were some other videos on Microsound before. So we have a GrainBuf unit generator, which generates every new grain where the trigger input receives 1 after 0 or negative value. No, not 1, by the way, any value bigger than 0. And for those trigger signals we use impulse unit generator with frequency specified by the t-frag control signal. That t-frag is also used to specify the duration and is multiplied by overlap parameter, which, if bigger than 1, the grains will start to overlap, and if it's smaller than 1, then there will be gaps between subsequent grains. So we make a periodic granular sequence, and the position for every new grain, or the point from which it will be taken from the buffer, from memory, is specified by this phasor, which generates linear ramp from 0 to number of frames in the buffer, or number of samples in the original sound file. This is our guitar sample with the arpeggio and gentle strum, and here is what GrainBuf does. So what we get is the sample playback from memory, but by the use of granular synthesizer. It's a granulator. Now I'd like to make this overlap a bit bigger. Let's put it to 8 in order to exaggerate what I want to talk about here. Okay. Now what if in this configuration I will decrease the post rate value, and the post rate is the rate of this phasor, which tells GrainBuf from which point to read new grain. We get a low pass filter, and if I will increase the overlap, the cut will be deeper, and if I decrease it, the filter effect goes out. Let's take a look at this effect with the white noise as input. I will override with this buffer recorder a signal in the memory with the white noise. Just in case, let's set it one more time. Make this a bit quieter, because white noise is a rather loud signal. And here we have a white noise. As I start to decrease the position rate lower and lower, we start to get comp filter. Yeah, we see that from the side of Nyquist frequency, notches start to appear. Yeah, and the lower the frequency, the bigger the amount of notches. Yeah, and so on. If I do the same thing with rate, which is a speed at which the grain is read from the memory, then I get to a certain degree a similar effect, but with a bit different result. As you can see, again low pass, and then we start to see notches. Yeah, the picture can be explained as follows. If I start to make the phaser a bit slower, what happens is the first grain stops at certain moment, yeah, and the next grain starts a bit earlier from the point that was already played by the previous grain. Yeah. So if there is an overlap, then we start to hear copies of the signal delayed from each other. Yeah. And the bigger the slower is the phaser, this guy, the bigger is the delay time between them. Yeah. Let's make this range a bit bigger. Let's put it down like this. You see this comp filter effect, yeah, very exaggerated. We don't even hear the original content now. And the lower I get, we start to hear the distinguished copies, no, distinguished stutter effect, yeah, kind of a stutter effect. And so on. But as we see, we not only get the delay effect or comp filter effect, we also do a time stretch, yeah. So what we have is finite impulse response filter, yeah. But it's not just a filter, it's also a time stretcher in a case where when we change the post rate signal. And if we do the same with the rate parameter, we also do that thing, but at the same time we change the pitch, yeah. So we introduce that finite impulse response filter effect plus the pitch shift. What I would like also to note is that if we use finite impulse response filter with interpolated delay lines, very simple one, and we will start to change the delay time, yeah, we will hear the pitch will change as well, yeah, until the delay time value becomes static, yeah. During the change, the pitch will start to change as well. But here we don't have this effect. We can change the pitch independently, and the time stretch, and the delay time as well. How we can do that? As you could see, this guy rate changes a delay time, and the post rate changes the delay time, yeah. But the T-frag also does that. So once I specify a certain delay, let's put it lower, yeah. Now I can adjust. Okay, a bit bigger, yeah. So this is the thing, we have three effects at once: pitch shift, time stretching, and a finite impulse response with very interesting and unusual characteristics. Let's now make this stereo sampler, which will have two grain buffs. Why two? Because I add modulators through the use of functions. Yeah. Now, if I will duplicate any of those functions, I have three here. One modulates t-frag, another one modulates rate, and the third one modulates post rate. Yeah. And then here I add those corresponding modulators to these parameters, and I use dupe, yeah, which basically duplicates anything, well, that this message gets sent to, yeah, and in this case it's function. Since I specify random phase here for every modulator, duplicating these functions will result in two sign-oscs with different phases, yeah, and when these signals, which will become an array of two signals, yeah, when they will get here, the multi-channel expansion mechanism of sclang will result in two granulators, one for left, one for right, with the different characteristics for duration, trigger frequency, rate, and position change rate. Let's take a look at what we can get then. Where is the overlap? Let's make it a bit bigger. Yeah. Okay. Let's start with the t-frag modulation. Put it to something like 3. And also I'd like to make a post rate a bit faster, so that we will see the effect better. Here is the situation in which comp filter basically destroys the harmonic content of the original signal, yeah. And then we will start to modulate it and disrupt the periodicity that produces this effect. Yeah. Pitch shift. Yeah. And without the modulation. Musically interesting result, I think. I hope you also think so. Let's take a look at the second parameter. This is rate. We will modulate rate now. This to 1, this to again to something like 0.75, 0.7, okay. Good. Okay, the frequency goes to something like 3, and flanger. We get a nice flanger. Or not a nice flanger, yeah? Okay. And the last one, the position change rate, yeah. Send. Let's make something like phaser. Something like phaser. So as you can see, we can find lots of interesting combinations of those parameters. We can change. By the way, I didn't. Let me show that as well. We can change the timing structure of the original material by modulating the position change rate drastically. Let's move it back to 1. And this back to something faster. You see now? Reset. We can change the pitch independently as well, and we can play with the delay times more or less independent from the TimeStretch and PitchShift effects. One of the ways that I like personally a lot is this. I included it in this file, is to take a sound file like where was it? This one, yeah, like this. As an example, yeah. And then this is a Ndef, well, same as Ndef above, with just a difference here. The T-frag has a lag, yeah, it's smoothed out so that different frequencies change a bit smoother. So what I like to do sometimes is take some material and then make that pulse rate, that phaser, to rather low value, which occasionally jumps to a faster value, but most of the time is rather low. And with this slow position change, I start to kind of explore what's in this buffer, yeah, and what can I get from this material. So here is the synth in the routine with some arbitrary settings. You can get this type of one-line settings from interfaces like this in Ndef. Ndef. It has this duck button. So once you set those sliders, they set the proxy or internal environment value of the Ndef, and then once you press duck, it will post the code that was sent to the proxy and the last positions of the sliders. So you can just copy it and put it as a preset, yeah, one of the variants to make presets, and then come back to the combinations that you like. So I wait for some time so that the musical material gets revealed, and then just change some of the parameters with these exponential random generators with corresponding ranges. Yeah, so let's take a listen to what we can get this way. And with this I will say till next time. In the next video I will talk about granular reverberation. We'll take a deeper look at what we can get with this GrainBuf based synth def, and see you.